Good day and welcome to One-on-One Maths Private Tutors. Today we are doing past paper revision for May-June 2024 paper 1-4 Cambridge O-Level. First, understand the instructions. Answer all questions. Use black or blue pen and use HB pencils for diagrams and graphs. Write your answer to each question in the space provided, and you must show your working wherever possible. Calculators must not be used in this paper. So for paper 1, we don't use calculators in O-Level, whether it's Cambridge or ZIMSEC. You must show all necessary working clearly. That's where the marks are. The answer doesn't really matter that much. It's the working. You might get the answer wrong, but if your working is correct, you might even get full marks. So this paper consists of 24 questions and a total of 80 marks. And it's 2 hours long. Now let's go to number 1. From this word, write down the letters which have a line of symmetry. A is a line of symmetry. This side is exactly as that side. So A is a line of symmetry. Also, T is a line of symmetry. If we put a line of symmetry there, this left-hand side is the same as the right-hand side. So T is a line of symmetry. No other letter has a line of symmetry. Rotational symmetry. If we take this N and we rotate, let's use this, through 180 degrees, it will remain an N. And if we rotate it through another 180 degrees, it will come back to, and so it has rotational symmetry of order 2. The rest of these do not have rotational symmetry. So our answer is N. Only N has rotational symmetry of order 2. The rest have order 1, which is not rotational symmetry. Let's go to question 2. At the start of the day, the mass of a bed is 4.628 kilograms. Later in the day, the mass of the bed is 4.693. Calculate the increase in mass of the bed. Give your answer in grams. So this is the final, this is the initial. So increase in mass is final minus initial, which is 4.693 minus 4.628. So we borrow 1 here, this becomes 8, and this becomes 13. 13 minus 8 is 5. 8 minus 2 is 6. 6 minus 6 is 0, comma, 4 minus 4 is 0. These are kilograms, but we want our answer in grams. So to convert from kilograms to grams, we multiply by 1,000. So 0.065 times 1,000. First put these zeros down as placeholders. 1 times 5, 5. 1 times 6, 6. And the rest are zeros. No need to write them. Then we count the decimal places. 1, 2, 3. 1, 2, 3. Then we put our comma here. So 65.000 is the same as 65. So we have answer as 65 grams. Now work out 0.3 times 0.02. 2 times 3, 6. Then we count the number of decimal places. 1, 2, 3. We have 1. Put a placeholder there. 1, 2, 3. Then we put our comma there and a 0, which will give us 0.006. Let's go to B. 15% of 40. 15% is the same as 15 over 100. And of in maths means times. So it's 15 over 100 times 40. 20 into 40, 2. 20 into 100, 5. 5 into 5, 1. 5 into 15, 3. Which will give us 6 as our answer. So we have 6 as our answer. Then we move to C. 7 minus 25 is the same as saying 7 plus 25. If the signs are the same, minus will give us a plus. 25 plus 7 is 32. Remember, show your working in the spaces provided. Now we go to number 4. ABC is a triangle with AC 5 centimeters, BC 10 centimeters. Using a ruler and compasses only, construct triangle ABC. So what we need is a ruler and compasses only. AB has been drawn for you, so this is AB. What we want is AC and BC. So AC is 5 centimeters. We take our compass. Our needle point should be at 0 here. Then our pencil point should be at 5. So we have measured 5 centimeters there. Now we take our compass needle point at A, the needle point at A. Then we draw an arc like that. This arc has to be seen. That is a mark. That is the working. We don't just want to see a triangle with no construction lines. So this arc has to be seen. Then we are told BC is 10. So again, we take our compass, the needle point at 0, then the pencil point at 10. The needle point of the compass is at 0. The pencil point is at 10. Then we take our compass, we put the needle point right at the end of our line B there. Then we draw an arc that is 10 centimeters from B. That's our point C. So from A, we have 5 centimeters. From B, we have 10 centimeters. Then we get our point C. Then we use our ruler to join A to C. Then we also join B to C, making sure that we are as accurate as possible. Using a pencil and a ruler, we join B to C. So there is our triangle. Remember, these curves from our compass have to be shown. That is the working. That's how you get full marks on construction. B, measure angle BAC. Which angle is BAC? BAC. So it's this angle we have to measure. To measure an angle, we use a protractor. So always carry your math set when you are going to the exams for paper 1 and paper 2, whether it's O-level, Cambridge or ZIMSEC or any other syllabus. So to use our protractor to measure an angle, the baseline, which is this line of the protractor, should be on one of the lines. So we decide to put it on AB. Then we choose a scale which is starting from 0. This one is starting from 0, 10, 20, 30, 40, 50, 60, 70. For me here it's 71 degrees. So my angle here is 71 degrees. So anything plus or minus 3 degrees is okay. So you can have 69, 70, 71, even 68, or you can have 72, 73, or 74. As long as it is within a reasonable range, we put our answer in the appropriate position. So this is 71 degrees. Remember, the unit of angles is degrees. Now let's go to question 5. The table shows information about a class of 28 students and the distances they lived from their school. Complete the table. So the total is 28. So if this is x, we can say x plus 11 plus 3 plus 6 will give us 28. X plus 11 plus 3 plus 6 is 20. Is equal to 28. So x is equal to 28 minus 20, which will give us 8. So here, to complete the table, we should put 8 there on the table. As it says, complete the table. We want a number here. A student is chosen at random from the class. Write down the probability that the student lives more than 1 kilometer from the school. So we look at distance of more than 1 kilometer. How many students are more than 1 kilometer? It's 3 plus 6, so it's 3 plus 6 out of a total of 28, which is 9 out of 28. So our answer is 9 out of 28. We cannot reduce these two lowest terms, so we put 9 out of 28. Simplify 6r plus 7s minus r plus 3s. So we collect like terms, 6r and minus r plus 7s plus 3s. Remember, a term moves with its sign. So when we are rearranging, let's not forget the sign. 6r minus r is 5r plus 7s plus 3s is 10s. So this will be 5r plus 10s. We cannot add unlike terms, so we'll just finish it there. Bananas cost X cents. Apples cost Y cents. Write an expression for the total cost of 7 bananas and 5 apples. Bananas is X, so it's 7X plus apples cost Y, 5 apples, 5Y. So we have 7X plus 5Y. Let's look at number 7. A square and a regular pentagon are joined along one edge as shown in the diagram. Calculate the value of x. From this, we can calculate this angle and that angle. The sum of angles in a polygon is equal to the number of sides minus 2 times 180. So for the square, which has 4 sides, we have 4 minus 2 times 180 as the sum of interior angles, which is 2 times 180, which is equal to 360 degrees. Now each angle A in a square is equal to 360 divided by 4. Since a square is regular, the size of the angles is the same. So each angle is 90 degrees. For the regular pentagon, we have 5 sides minus 2 times 180, which is 3 times 180, which is 540 degrees. If each angle is B, since interior angles are equal in a regular polygon, so we have 5 angles. So each angle B is equal to 540 divided by 5, which is 108 degrees. Now we have this angle as 108 degrees and that angle as 90 degrees. These are angles at a point, so their sum add up to 360. So we can say 90 plus 108 plus x is equal to 360. Reason angles at a point add up to 360 degrees. So 198 plus x is equal to 360. X is equal to 360 minus 198, which we can calculate like this. 0 minus 8. We borrow 1 there. This becomes 5 and this becomes 10. 10 minus 8 is 2. 5 minus 9, we borrow there. This becomes 2. This becomes 15. 15 minus 9 is 6. 2 minus 1 is 1. So we have 162 degrees there. 162 degrees is our answer. So what we need to understand is sum of angles in a polygon using the number of sides. Then to understand that in a regular polygon, all the angles are equal. So we divide by the number of sides to get the angle. Then angles at a point add up to 360 degrees. Then we can get x. Let's move on to number 8. Ahmed invests $4,000 at a rate of 1.5% per year, simple interest. Calculate the value of the investment after 2 years. Interest is equal to principal times rate times time for simple interest, which is 4,000 times 1.5 over 100 times 2. 100 into 101, 100 into 4,000, 40. 40 times 2 is 80 times 1.5. So we can say 1.5 times 80. 0, 8 times 5, 40, 0 don't carry 4. 8 times 1, 8 plus 4, 12. Number of decimal places is 1, so 120. Now, this is the interest, $120. The value of the investment will be equal to principal plus the interest, which is 4,000 plus 120, which is $4,120. So our answer is 4,120. Common mistake is to use the interest as the value of the investment instead of calculating the interest, then adding it on to the principal value. Let's move to number 9. The diagram shows the distance time graph of a cyclist for the first 2 stages of a race, A, B, and BC. Work out the average speed of the cyclist for the second stage, BC. For the distance time graph, the gradient is the speed. So for the second stage, we need this value here and that value, calculate the time lapse, and we are using kilometers per hour. So we need to convert this time in hours. Then the distance is already in kilometers. To calculate the speed, we need to calculate the gradient. So speed is equal to distance over time. Our distance is equal to 21, 2, 3, 4, 5, 6, 7. This is 27. This is 21. 27 minus 21, which is 6 kilometers. Our time is 9:30 minus 9 o'clock, which is 30 minutes. We need to convert this to hours. 30 minutes over 60 minutes is 0.5 hours. So our speed will be our distance 6 kilometers over our time in hours 0.5 hours, which will give us 12 kilometers per hour. So the trick here is we have to be able to use a graph to get the values. First, we have to convert our distance and time into the relevant units, which are used kilometers and hours. Then we have to know how to use a distance time graph to find speed. The speed is the gradient of the graph, and we are restricted to BC. So we have to calculate the average speed for BC. Let's go to B. A bus travels at an average speed of 20 kilometers per hour. Work out the time the bus takes to travel 50 kilometers. Speed is equal to distance over time. So we want to make time the subject of the formula. Time is equal to distance over speed, which is 50, our distance, over our speed, 20 kilometers per hour, which will give us 5 over 2, which is 2.5. So it will take 2.5 hours. Let's go to number 10. The diagram shows the fuel gauge of a car. This car has 40 liters of fuel in the tank. Calculate the amount of fuel that the tank contains when it is full. So let's look at the scale. We have 1, 2, 3, 4, 5 graduations corresponding to 40 liters. When it's full, it will have 1, 2, 3, 4, 5, 6, 7, 8. 8 graduations should correspond to our unknown x. From this ratio, we can form an equation. X over 40 is equal to 8 over 5. Now we can say x is equal to 8 over 5 times 40. 5 into 5, 1. 5 into 40, 8. 8 times 8, 64. So x is equal to 64 liters. So we'll put our 64 here. The car uses 5.4 liters of fuel for every 100 kilometers traveled. Calculate the amount of fuel that the car will use in a journey of 300 kilometers. Okay, so 5.4 liters corresponds to 100 kilometers. 300 kilometers corresponds to our unknown x. So we can say x over 5.4 is equal to 300 over 100. 100 into 100, 100 into 300, 3. So we now have x being equal to 3 times 5.4. Then we do our calculation there, 5.4 times 3. So we say 3 times 4, 12. 2 down, carry 1. 3 times 5, 15, plus 1, 16. Then count our decimal places. 1 decimal place. Put 1 decimal place here. So it will be 16.2 liters. Let's look at number 11. Tom's pet eats 3/5 of a tin of food each day. Tom needs food for his pet for 12 days. Calculate the number of tins of food Tom needs to buy. So 3/5 times 12, which is 12 times 3, 36 over 5. 5 into 36, 7 point, remember 1, 0, 5 into 10, 2. Number of tins are whole numbers. So we round up this number to 8 tins. So this is to the nearest whole number. So he needs 8 tins because he cannot buy 7.2 since number of tins are whole numbers or natural numbers. Solve this, so we expand the brackets. We have 8x minus 12 plus 5x plus 25 is equal to 20. Collect like terms. 8x plus 5x plus 25 minus 12 is equal to 20. 8x plus 5x is 13x. 25 minus 12 is 13, equal to 20. 13x is equal to 20 minus 13. 13x is equal to 7. Divide both sides by 13. X is equal to 7 over 13. So our answer is 7 over 13. Let's move to question 13. The pie chart shows the proportion of junior members and senior members at a gym. There are 120 more senior members than junior members. Calculate the total number of junior and senior members at the gym. Let the number of juniors be equal to x. The number of seniors is equal to x plus 120. Since we are told there are 120 more senior members than junior members. So for the junior members, we have 60 degrees. So 60 corresponds with x, which is the number of junior members. The angle that corresponds to seniors is 360 minus 60, which is 300 degrees. So this is 300 degrees corresponding to the seniors. So 300 degrees corresponds to the number of seniors, which is x plus 120. So using these two ratios, we can form an equation. So we can say 300 over 60 is equal to x plus 120 over x. Now we simplify this equation by cross multiplying here. So we have 300 x is equal to 60 times x plus 120. So 300 x is equal to 60 times x, 60x plus 120 times 60, 0, 0, 6 times 2, 12, 2 carry 1, 6 times 1, 6 plus 1, 7, plus 7,200. So now we take this to that side. We now have 300x minus 60x equals 7,200. 300x minus 60x is 240x equal to 7,200. Divide both sides by 240. 240 cancels there. 7,200 divided by 240 is the same as 720 divided by 24. 24 into 72. 24 times 3. 3 times 4 is 12. 2 carry 1. 3 times 2 is 6 plus 1, 7. So 24 into 72 is 3. 24 into 0, 0. So x is equal to 30. Now calculate the total number of junior and senior. We want the total. So the total is x for juniors plus x plus 120 for seniors. X is 30, so we will say 30 plus 30 plus 120, which will give us 180. So our answer here is 180 people at the gym. Solve the simultaneous equations. Show all your working. So we can say this is equation 1, this is equation 2. So we can say from 2, x is equal to 6y plus 6. Now we can substitute x in equation 1. So we take this whenever we see x, we put 6y plus 6. So we have 2 factor of 6y plus 6 plus 3y is equal to 7. We expand these brackets, 12y plus 12 plus 3y is equal to 7. Collect like terms, take this to that side. We have 12y plus 3y is equal to 7 minus 12. We simplify the 15y is equal to 7 minus 12 is minus 5. Divide by 15 on both sides. Y is equal to minus 5 over 15. 5 into 5, 1. 5 into 15, 3, which will give us minus 1 over 3. So it's minus 1 over 3 for y. Now we can substitute y in 2. X minus 6 times minus 1/3 is equal to 6. X minus times minus is plus. 3 into 3, 1. 3 into 6, 2, plus 2 is equal to 6. Taking 2 to that side, we have x is equal to 6 minus 2, which will give us 4. So we have x is equal to 4, y is equal to minus 1/3. So that is our answer. Remember, show all your working. Let's go to number 15. By writing each number correct to one significant figure, estimate the value of. So each number must be written to one significant figure. 2.87 to one significant figure is 3 times 396.5 to one significant figure is 400. So times square root of 400 over 1.92 to one significant figure is 2 squared. Okay. So how did we come up with these figures? 2, 3, and 400. 2.87 to one significant figure. The first significant figure is the first non-zero number from the left. So we have to use the next position, which is this number, to decide whether we are rounding up or rounding down. 8 is 5 or more, is greater or equal to 5. If this digit is greater or equal to 5, we round up. We increase this value. If this digit is less than 5, it remains like that. and then we drop all the other values or put zeros as placeholders. Now, 8 is greater than 5. So we increase here to get 3. So 2.87 to one significant figure is 3. For 396.5, the first significant figure is this position where there is 3. So we now look at the next position, which is 9. 9 is 5 or more, or we can say 9 is greater or equal to 5. So we increase here. This will become 400.0, which is just 400. That's how we got this 400. And for 1.92 to one significant figure, this is the figure we are interested in. So we look at the next value. If it's more or equal to 5, which is the case here, 9 is greater or equal to 5, then we increase this value to 2. That's how we got this 2. So 3 times square root of 400 over 2 squared, which is equal to 3 times the square root of 400 is 20 over 2 squared is 4. 4 into 4, 1. 4 into 20, 5. 5 times 3, 15. So our answer is 15. Now we move to number 16. A, B, C, and D are points on the circumference of a circle center O. Angle BCD is equal to 58 and angle DBC is 72. Marked there. Complete the statement below. Angle DAB is equal to DAB, which is this angle. This angle is equal to 180 minus 58, because opposite angles of a cyclic quadrilateral are supplementary. They add up to 180 degrees. So 180 minus 58, 7 there, 10, 10 minus 8, 2, 7 minus 5, 2, 1 minus 0, 1. So it is equal to 122 degrees, because opposite angles of a cyclic quadrilateral are supplementary or add up to 180 degrees. Find the angle DOC. DOC. Angle at the center is twice the angle at the circumference. So DOC is 2 times 72 degrees. 2 times 72, which is 2 times 2, 4, 7 times 2, 14, which is 144 degrees. So we have 122 here, 144. Find angle BCO. BCO, which is this angle here. We can find OCD. OCD is equal to 180 minus 144 all over 2. This angle here is a base angle of an isosceles triangle. OCD, since these sides are equal, OC and OD are radii. So these are base angles of an isosceles triangle. 180 minus 144, 7, 1. 10 minus 4 is 6. 7 minus 4 is 3. 1 minus 1. So this is 36 over 2, which is 18 degrees. So this angle is 18 degrees from 58. So we can say 58 minus 18, which will give us 40 degrees. So our angle BCO is 40 degrees. Put here 40 degrees. Now let's continue to number 17. The table shows the time that each of 60 children spends in a play area. Draw a cumulative frequency diagram to show this information. So using this information, we have to create a cumulative frequency table. So we have time in minutes and we have cumulative frequency. So for our time, we have time less than or equal to 0, because these four are between 0 and 10, but not including 0. So equal to or less than 0, we have nothing. So we have 0. Then time less than or equal to 10, we have 4. Time less or equal to 40, we have 7 plus 4, which is 11. Then time less than or equal to 60, we have 8 plus 7 plus 4, which will give us 19. Then time less than or equal to 90, we have 24 plus 8 plus 7 plus 4, which is equal to 43. Then time less or equal to 120 is a total sum, which is 60. Now we plot the points. Time 0, cumulative frequency is 0. So it's this point, 0, 0. When time is 10, you see here, the cumulative frequency is 4. 1, 2, 3, 4. So our point is there. When time is 40, cumulative frequency is 11. Plot your point there, 11 for cumulative frequency, time is 40. When time is 60, cumulative frequency is 19. Plot your point there, 19 is here. When time is 90, which is halfway between 80 and 100, which is here, the cumulative frequency is 43, which is here. When time is 120, the cumulative frequency is 60, which is here. To plot our graph, we do not use a ruler. We use freehand to join the points. So this is our cumulative frequency diagram. Use your diagram to estimate the median. So the median is at the 50th percentile, which is at 50% of the cumulative frequency, which is 50 over 100 times 60, which is half of 60, which is 30. So we go to our cumulative frequency diagram. At 30, we find the time corresponding to that value, which is here. And we have to show these lines on the graph how we find the median value. If they are not seen, then there will be no marks because you are asked to use your diagram. When working with graphs, it is important to understand the scale used in axes. These two axes have different scales. In the time axis, 20 units are used to represent 10 small squares. So each square is representing 20 divided by 10, which is 2 units or 2 minutes. So to read this value here, we start from 60, 62, 64, 66, 68, 70. 70 is here. Then 72, 74. So the value there is 74 minutes. On this axis, one small square is representing 1 unit because this is 0 to 10. So each small square is 1 unit. So 30 corresponds to 74 minutes. Now we are asked for the interquartile range. So we need to use the graph to find the lower quartile and the upper quartile. Our lower quartile is the 25th percentile, which is 25 over 100 of our total cumulative frequency, which is 60. This is 1/4 of 60, which is 15. So we go to our graph and find the lower quartile at 15. 15 is here, and we draw a horizontal line there, and then a vertical line from there to find this value of the lower quartile. 1, 2, 3, 4, 5. So that's 50, 52. For the upper quartile is the 75th percentile, which is 75 over 100 times 60, which is at 45. Now we go to our graph. At 45, which is here, we find the upper quartile, which is here, which we can estimate to be 82, 4, 6, 8, 90, 92, 4, which is 94. So interquartile range is 94 minus 52. 94 minus 52, which is to the 9 minus 5, 4. So 42 minutes. Again, the calculation of the upper quartile using the graph, which means these lines, has to be seen by the examiner. That's where the marks are. That's the working you carry out when you use your diagram. And remember, all these lines and curves are drawn using a pencil. You do not use a pen to draw these diagrams. Let's go to question 3. The number of children who spent more than 80 minutes in the play area. So we go to 80 minutes, bring up our graph from 80 minutes. Then when it meets the graph, we draw a horizontal to find the number of children there, which is 35 there. But 35 are the ones who spent less because it's cumulative frequency. We want those who spent more, which are above there. So our final answer should be 60 minus 35. So we will say 60 minus 35 to calculate those who spent more, which will give us 25. So our answer is 25. Now we move on to question 18. In this table, P is directly proportional to the square of Q. Calculate the value of A and B. So we have P is directly proportional to Q squared. Then we have P is equal to KQ squared, where K is our constant of proportionality. Now we have these values that are given. We can find K by substituting P and Q. 12 is equal to K times 2 squared. 12 is equal to 2 squared is 4, so it's 4K. Therefore, K is equal to 12 over 4, which is 3. Now we can use this equation. Now our equation is P is equal to 3Q squared. When P is equal to A and Q is equal to 7, A will be equal to 3 times 7 squared. A is equal to 3 times 49. 49 times 3, 9 times 3, 27, 7 down, carry 2. 4 times 3, 12 plus 2, 14. So A is equal to 147. To find B, we substitute in this equation. So 48 is equal to 3B squared. Divide both sides by 3. B squared is equal to 3 into 4, 1. Remainder 1. 3 into 18, 6. B squared is equal to 16. Square root both sides. B is equal to plus or minus 4. Remember, the square root can be positive or negative. Now we have A as 147, B is plus or minus 4. Now we move to number 19. Functions. F of x is equal to 2x minus 5. Find f of 11. F of 11 is equal to 2 times 11 minus 5. So wherever we find x, we substitute with 11. So 2 times 11 is 22 minus 5, which is equal to 17. So our answer here is 17. Find the inverse of x, f to the minus 1 of x. So we say y is equal to 2x minus 5. Substitute f of x with y. Then we switch x and y. X is equal to 2y minus 5. Then we make y the subject of the formula. Take minus 5 over to that side, it becomes positive. X plus 5 is equal to 2y. We divide both sides by 2. 2 cancels here. Now we have y is equal to x plus 5 over 2. So our inverse becomes x plus 5 over 2. Solve f of x is equal to x squared plus x minus 11. F of x is equal to 2x minus 5 from this statement. So whenever we see f of x, we put 2x minus 5. So the equation will now be 2x minus 5 is equal to x squared plus x minus 11. We rearrange. We take everything to the right-hand side. 0 is equal to x squared plus x minus 2x minus 11 plus 5. Then we have x squared, x minus 2x is minus x, minus 11 plus 5 is minus 6 is equal to 0. Then we factorize. We have x squared minus 3x plus 2x minus 6. We have broken down minus x into factors of minus 6x squared. When we multiply these two, we get minus 6x squared. And when we add them, we get minus x. So now we have x factor of x minus 3 plus 2 factor of x minus 3. We factor out x minus 3 and we remain with x plus 2 being equal to 0. Remember, all this is equal to 0. So either x minus 3 is equal to 0 or x plus 2 is equal to 0. X is equal to 3. We take this that side, or x is equal to minus 2. So our answer will be x is equal to 3 or x is equal to minus 2. When we move over to question 20, the matrix N satisfies the equation 3n is equal to n plus 5 times 4, 0, 6 minus 2. Find n. So now we collect like terms. 3n, by moving this n to that side, it becomes minus n is equal to 5, 4, 0, 6 minus 2, which means 2n is equal to 5 times 4, 0, 6 minus 2. Divide both sides by 2. N becomes 5 over 2 times 4, 0, 6 minus 2. Then we multiply each term by 5 over 2. 2 into 4, 2. 2 times 5, 10. So we 10 there. 5 over 2 times 0 is 0. 2 into 6, 3. 3 times 5, 15. We have 15 there. 2 into minus 2, minus 1. Minus 1 times 5, minus 5. So that is our n. So n is 10, 0, 15, minus 5. That is our answer. Let's go to question 21. Prism A and prism B are mathematically similar. In the diagram, the cross sections of the prisms are shaded. The volume of prism A is 500 cubic centimeters. The length of prism A is 50 centimeters. The area of cross-section of prism B is 16 square centimeters. Calculate the length of prism B. So we are given cross-sectional area of prism A. We can calculate the cross-sectional area of prism A. Volume is equal to area times length. Our volume is 5,000 cubic centimeters for A, and the length is 50 centimeters. So we can find the cross-sectional area of A. So the area of A is 5,000 over 50, which is 100 square centimeters. So this is 16 square centimeters. This is 100. Now that we have the area, we want to find the linear scale factor for A, which is the square root of 100, which is 10, and the linear factor for B, which is square root of 16, which is 4. So what we are saying is 10 centimeters on A is represented by 4 centimeters on B. So we're saying length on A to length on B. Length on A is 10 centimeters. Length on B is 4 centimeters. If we have a length of 50 on A, what is the length on B? If we have 50 centimeters on the side of A, what is the length on the side of B, which we may call X? So using this ratio, we may solve X over 4 is equal to 50 over 10. Now we can cross multiply to have X is equal to 50 over 10 is 5 times 4, which is 20. So our answer is 20. So the first thing is to find a similar measurement. We are given area at B. We can use these values to find area on A. Once we have the area, we find the length factor on A and the length factor on B. To reduce from square centimeters to centimeters, we square root so that we have root of 100, which is 10, and root of 16, which is 4. Now this means a length of 4 centimeters on B is corresponding to a length of 10 centimeters on A. Now we are given 50 centimeters there. We have to find the corresponding length on B, which comes up to 20. Now let's move on to question 22. Rearrange the formula to make X the subject. Now we get rid of fractions by multiplying the left-hand side and the right-hand side by X minus 3. So it becomes A times X minus 3 being equal to 5B plus 2X over X minus 3 times X minus 3. X minus 3 cancels there. So now we have X minus 3A being equal to 5B plus 2X. Now we take all terms with X on one side and all terms without X on the other side. So we have AX minus 2X, and we take this to that side, being equal to 5B. When we take this to that side, it becomes positive plus 3A. We factor out X. A minus 2 is equal to 5B plus 3A. We divide both sides by A minus 2. A minus 2 cancels there. X is equal to 5B plus 3A over A minus 2. That becomes our answer, 5B plus 3A over A minus 2. Now let's move to question 23. AB is a line segment joining A minus 2, 5 and B 1, 3. So we must have a sketch that will usually help in the analysis. Our X, our Y there, minus 2, 5, can just estimate minus 2, 5 to be there, and 1, 3, 1, 3 there. So this is point A, this is point B. So our line segment AB is here. B is the midpoint of the line segment AC. So we have a line segment AC there, because B is the midpoint, which means AB is equal to BC. Find the coordinates of C. So we want the coordinates of C. So how do we work it out? We use the equation of midpoint. Coordinates of the midpoint are x1 plus x2 over 2, y1 plus y2 over 2. Now we are given the coordinates of the midpoint. So we can say 1, 3 is equal to x1 and x2. So this is x1, y1, and C is x2, y2. These are the coordinates of C. So the midpoint is at B here, which are these points. B is 1, 3. A is -2, 5. So the coordinates of the midpoint, 1, 3, will be equal to x1 is -2, which is the x-coordinate of A, plus x2, which is the x-coordinate of C, which we are looking for, over 2, and y1, which is the y-coordinate of A, plus y2, which is the y-coordinate of C we are looking for, all over 2. Now, we may compare this being equal to that and this being equal to that by saying 1 is equal to -2 plus x over 2. We multiply both sides by 2, and we have 2 is equal to -2 plus x2 is x2, which is our x-coordinate for C. Take this to that side. We now have 2 plus 2, which is 4, is equal to x2. So our x2, which is the x-coordinate of C, is 4. We do the same by comparing the y-coordinates. So 3 is equal to 5 plus y over 2. Multiply both sides by 2. 2 cancels there, and we have 5 plus y. Take this over to that side. Y becomes 6 minus 5, which is equal to 1. So our y-coordinate here is 1. So coordinates of C are 4, 1. And that is the answer. Let's continue to B. The length of AB is root T. Find the value of T. AB is this. So we construct a right angle triangle. The length of AB, or the modulus of AB, is equal to square root of our x value here minus the x value there, which is 1 minus -2 all squared plus difference in our y values squared, 3 minus 5 squared. So here we are using Pythagoras theorem. 1 minus -2 is this length here, horizontal x length, and 3 minus 5 is this length here, the vertical length of a right angle triangle. And AB is the hypotenuse, which is the length we are looking for. 1 minus -2, it's 1 plus 2. 1 plus 2 is 3. 3 squared plus 3 minus 5 is -2. -2 squared, which will give us 3 squared is 9. So square root of 9 plus -2 squared is 4, which will give us square root of 13. So the length of AB is square root of T. The length of AB is equal to square root of T, which is equal to square root of 13. Therefore, T is equal to 13. So our answer is 13. Let's go to C. Find the equation of the line perpendicular to AB that passes through A. So we want equation of this line, which is perpendicular to AB and passes through A, which is minus 2, 5. First, we need to find the gradient of AB so that we find the gradient of the line. So we start by saying gradient AB is y1 minus y2 over x1 minus x2, where this is x1, this is y1, this is x2, this is y2. So we say y1, 5 minus y2, 3 is equal to 5 minus 3 over x1 is minus 2, x2 is 1. So we say minus 2 minus 1, which will give us 5 minus 3 is 2, minus 2 minus 1 is minus 3. So gradient of AB is minus 2/3. Now want gradient of the perpendicular, which is minus 1 over the gradient of AB, which is minus 1 over minus 2/3. The negatives cancel, then this becomes 1 times the inverse of 2/3, which is 3 over 2, which is 3 over 2. That is the gradient of the perpendicular. Now, line of an equation is y is equal to mx plus c. And our value for m is this gradient, which is 3 over 2. Our x is equal to minus 2 on the perpendicular, and our y is 5. So we substitute so that we find the value of c. 5 is equal to minus 3 over 2 times minus 2 plus c. The 2's cancel, and we remain with minus 3 here, so 5 is equal to minus 3 plus c. C is equal to 5 plus 3, which is 8. So now we have our value for c. The equation becomes y is equal to, our m is 3 over 2, x, our c is 8 plus 8. So our answer is 3 over 2, x plus 8. The equation in the form y is equal to mx plus c. We go to question 24. Vectors. A, B, C, D is a quadrilateral. H, K, L, and M are the midpoints of AB, BC, CD, and AD respectively. AB is equal to 2A. This is AB, 2A. Since H is a midpoint, AH is equal to A, HB is also equal to A. These are equal and in the same direction. BC is equal to 2B. BC is equal to 2B. Since K is a midpoint, BK is equal to B. KC is equal to B. AD is equal to 2D. AD is equal to 2D. Since M is a midpoint, AM is equal to D, and MD is also equal to D. Take note of the direction of B, A, and D. Express as simply as possible in terms of A, B, or A, B, and D. HK. HK is from H to K. So the route we can take using A, B, and D is A plus B. So HK is equal to A plus B. Let's go to B. CD. CD is this vector here, C to D. So we can take this route from C to B plus BA plus AD. So from C to B, it's going against 2B, so it's minus 2B. B to A, it's going against AB or against 2A, so it's minus 2A. Then AD is in line with 2D. AD is 2D, so plus 2D. So that is our answer. Or we can factorize 2 bracket minus B minus A plus D, which we can write as 2D minus B minus B minus A. So any one of these can do. 2D minus B minus A. ML. ML is this vector here, M to L. L is the midpoint of CD. So we may take this direction from M to A, which is minus D plus AB, which is 2A, plus BC, which is 2B plus 2B, plus CL. CL, it's a half CD, since L is the midpoint of CD. CD is this, so plus half times 2 bracket D minus B minus A. 2 cancels here. We now have ML being equal to minus D plus 2A plus 2B plus, we remove the brackets, D minus B minus A. Then we collect like terms. ML is equal to minus D plus D, 2 plus 2A minus A plus 2B minus B, which is equal to minus D plus D cancels out. 2A minus A is A, 2B minus B is plus B. So our final answer is A plus B. So ML becomes A plus B. That is the end of the question paper. Thank you.